Alright, so in the last video we talked about what happens if your function is a power function, and we learned that the derivative of the power function is the power rule. And so in this video we want to take a look at exponential functions, and so that is a to the x, and we will see that the derivative of an exponential function is actually a constant multiple of the exponential function. So if we're given a to the x, the derivative is a to the x times natural log of a. Good, so in particular, right, if a is equal to e, if we have e to the x, the derivative of that function is just e to the x. And so that's kind of an amazing little feature right there. So the exponential function here is the only function whose derivative is itself. Good, alright, so we want to be sure and distinguish between these two kinds of functions. So this is again a power function on the top, power function, and this is an exponential function. Okay, good. So I think we'll just briefly take a look at the rule. How is this? How did we get this expression? So if we have f of x is a to the x, what happens when you plug that into your definition of the derivative? We would have a to the x plus h minus a to the x over h. This is just to let you see how the algebra works out here. You can rewrite that as a to the x times a to the h minus a to the x. And notice then that I could factor out the a to the x, and then I'd be left with just this quantity here, a to the h minus 1 over h. And so it's this quantity right here that is the thing that's going to take a little bit of time to work. So it turns out that this is going to be the natural log of a, but we're not going to prove that. But it does turn out that this is one way to define e. So some people will say that alternative definition for e, some people will say that e is the number so that e to the h minus 1 over h as h goes to 0 is equal to 1. You can imagine this is a little hard to work with as a definition, and so that's why we kept our original definition, but that definition is out there. Very good. All right, so I'm going to pause here and we'll switch gears for a second. Okay, so just as a reminder of our rules thus far, right, we can build a little table, f prime. We had a constant function, the derivative was 0. X to the n is n x to the n minus 1. And in fact, in that, you might consider the line, right? If you have, I'll go ahead and put it over here, mx plus b. The slope is just m, right? And now we also have a to the x is a to the x natural log of a. And just as a special case, e to the x will be e to the x. Good. So what we want to do now is talk about some general derivative rules. And so in particular, how would I differentiate? Differentiate just means to take the derivative, right? Differentiate a constant times a function. Okay, as it turns out, the derivative, I'm going to denote the derivative using the prime notation here. That's going to be a constant times the derivative of the function. Okay, so for example, if I had 3 times x to the 4th, how would I differentiate that? Well, I would take the 3 out, and then I would differentiate x to the 4th, right? And so that would be using our power rule, and so I would have 4x cubed there. Good. And so the derivative then would be 12x cubed. Good. So that's how you would differentiate a constant times a function. You just pull the constant out and differentiate and then multiply through. Good. So similarly, how would I differentiate 1/2 x to the 10th power? I would take the 1/2 out and then differentiate x to the 10th, and so that would be 1/2, and then I'd have a 10x to the 9 power, right? And so that would just be 5x to the 9th. Good. All right. So now we want to differentiate a sum of two functions, f of x plus g of x. Okay, and so as it turns out, the derivative of a sum is the sum of the derivatives. It's not hard to show that, and our book shows that. So for example, if I want to differentiate x squared plus e to the x, right? My rule is saying that I can take x squared and differentiate that, plus e to the x and differentiate that, and then add the two things together. So this first one would just be 2x to the 1 power plus e to the x. Good. So putting these two together, if I have, how would I differentiate 3x squared minus 4 times 2 to the x? Well, that would be 3 times the derivative of x squared minus 4 times the derivative of 2 to the x. And so that would be 3 times 2x to the 1, right? Using the power rule. And then minus 4 times 2 to the x times the natural log of 2 using our exponential rule. Good. So altogether then that would be 6x minus 4 times 2 to the x times the natural log of 2. Very good. Those are the rules we're going to be using. Maybe we'll summarize them in this table again. So I had c, x to the n, and a to the x. Those are my general rules, right? So c is 0, n x to the n minus 1, and a to the x natural log of a. And then, for the more general case, this is ff prime. If I have a constant times a function, the derivative is a constant times the derivative, and f plus g is just going to be f prime plus g prime. Good. So we're going to use these rules now in the worksheet in class. See you then.